All right, so the next lesson in this geometry unit is on triangles. All right, so there's a couple properties I just want to go over with triangles, and then I'm going to go over go through some examples as well. Right? So the first thing, and I think we all know this, is it was in the review that whenever you have a triangle, the angles inside of the triangle add to 180. So I'll write 180 in here. So yeah, angles in a triangle add to 180. So 180 degrees. All right. So yeah, so that was in the review. Yeah, I'm sure you guys were all aware of that. Now there are some certain special types of triangles as well. All right. The first one is called a scalene triangle. And that's when you have a triangle and all three sides and all three angles have different measures. Okay, so that's a scalene triangle. The only property that you can apply to a scalene triangle, so let's go like that, and that, and that. And these, just to indicate their different lengths, we'll just put different slashes there. So the only property that you can actually apply here is that they add to 180. So all triangles at angles in triangle add to 180, and for the scalene triangle, that's the only property that you can actually apply. Right? Now, there's another type of triangle which you guys have probably heard of before. It's called isosceles, and this is when two angles and two sides are equal. All right, so if I was to draw an isosceles triangle, perhaps it will look something like this, where these two sides are equal. Now, the key thing here is that when you have the two equal sides, the angles across from them are also equal. So the angles across from the equal sides are equal. All right, so if you look here in this, this diagram here, notice that these are the two equal sides, and then the angles across from them are equal, right? And vice versa. Okay, so these are two equal angles. The sides across from them are equal. All right, so that's an isosceles triangle. Now the other triangle, or actually, sorry, before I go on to the next type of triangle, what you're going to end up seeing in a lot of diagrams is a circle. So we'll see a circle, and you'll see like at the center, right, you'll see like two lines being connected like this, and then what that'll do is it'll create a triangle. And let's just say, for example, that this interior angle here is looks like it's close to 90. Let's call it 80 degrees. Right. And we want to figure out what this angle here is. All right, so even though it's not labeled green, what you would do is you would whenever you spot a triangle or a circle in any of these questions or diagrams, what you want to do is get in the habit of just marking off the radius or the radii being equal. And what this does is it creates isosceles triangles. So whenever you see it, again, whenever you're going through your questions here, whenever you spot a circle, just right away, just mark off the radii being equal, because what that does is it creates isosceles triangles. All right, so now it is possible to actually figure out what this angle here is. Since angles in a triangle add to 180, right? So if this middle angle here is 80 degrees, and if I take 180, subtract 80, I got 100 degrees left over. Okay, so that means that these two angles here must add up to 100. Now, since they're equal, we're just going to divide them by 2. Right? So they're going to be equal. That means that they have to be, oops, percentage there. They have to be 50 degrees each. All right, cool. So this angle here is actually turns out to being 50 degrees. Right? All right, so again, whenever you see a circle, mark off the radius being equal. That creates isosceles triangles. So if this interior angle, central angle here is 80 degrees, then that means you got 100 degrees left over between these two. And this is an isosceles triangle. The angles opposite from the equal sides are equal. So therefore, they're each 50 degrees. Cool. So that's an isosceles triangle. Now, the third type of triangle is an equilateral triangle. All right, so an equilateral triangle, all 3 sides and all 3 angles are equal. All right, so what that looks like is something like this, where all 3 sides are equal. All right, so what that means is that if all 3 sides are equal, then all 3 angles must be equal. And if angles in a triangle add to 180, and if I divide that by 3, each one of these angles has to be 60 degrees. So, so this is 60, 60, 60. Since angles in a triangle add to 180. All right, so for equilateral triangles, each angle is 60. All the sides are the same. Okay. Cool. All right, so what I'm going to do now is just kind of go through some examples. Now, I took these ones here. So I'll show you where I got these. So off your package, if you go through the worksheet package, you come across a page where it says 2.3 angle properties. Now, I know it's sideways here. Actually, I think I typed this title in after I photocopied, so you might not, the title won't be there, but you'll see this page. So what this page does here is it just summarizes what I just went through. And following that, there are some practice questions. Now, I cut it out of the first worksheet here. I'm going to go through 18, 19, 20. Right? But there's a few more. Yeah, so there's a few more practice questions, all right, that you can work through as well. All right, so so going back to this one here. All right, so this is number 18 on that package question. Now it's not, the numbers here are a little bit blurry, but hopefully you can read it. All right, so let's use the breakdown. All right, so what it's saying here is this angle here is 20 degrees. Right? You might not be able to see that, so I'm just gonna write that out there. All right, so that's 20 degrees. And what we want to do is we want to figure out the angles 3, 4, 5, and 6. All right, so like I said, in the with the isosceles triangles, whatever you want to do, whenever you spot a circle in diagram, just right away, just mark off these radius being the same. Right? So you can see that we have 3 radii, right? And this angle is 20 degrees. Right? So this triangle here is an isosceles triangle. Right? Now this angle turns out to be 20 degrees. So since the radii are equal, angle 3 here must be also 20 degrees. Right? Since it's an isosceles triangle, the angles opposite equal sides are equal. All right. Next up, angle 4, which is right here. Angles in a triangle add to 180, so I'm just going to take the 180 minus the 20 degrees twice, right? Because those are the 2 angles, and what we have left over is 140. Okay, so that means angle 4 there is 140 degrees because angles in a triangle add to 180. All right, next up, just grab a different color here. This angle over here, angle 5. All right, so to find angle of 5, what I'm going to use the factors that angles on a line add to 180. Right, so that's going back to the basic properties there. All right, so angle 5 here is going to be 180 minus the angle 4, which is 140. All right, so we have 40 degrees left over. All right, so this angle here is 40 degrees. And again, we have another isosceles triangle. So angle 6 and this angle are equal. So if I take 180, so if I take the 180 minus the 40, I got 140 degrees left. I'm going to divide that by 2 because those two angles are equal. And I got 70 degrees. So that angle 6 there must be 70 degrees. All right, so again, yeah, so this isn't the clearest of pictures, I'm aware, but hopefully you guys get the idea. All right, so again, whenever you spot a circle, just mark the radii being equal. And that what that does is it creates a bunch of isosceles triangles that you can work with, and then basically just apply that property. All right, cool. Now, this next one here, it's also going to work. We're also going to work with parallel lines. All right, so yeah, so notice that this line here is parallel to this line. So the first angle I want to find here is angle 1, right there. So what you'll see here is if that's angle 1, if I trace this angle here, which is 170 degrees, what you'll notice is it's a sideways F, right? So it's an F angle. So that means angle 1 here must also be 117 degrees, because F angles, corresponding angles, are equal. Cool. All right, so next one, angle 2. I'm just going to change colors here. Angle 2, which is this angle here. You notice that with angle 1, it creates a straight line. Okay, so angle 2 there is going to be 180 minus 117, which is 63 degrees. So this angle here is 63 degrees. All right, so far we just used the parallel lines property, or parallel line property and angles on line. So now we're going to be working to find angle 3 here. You can see that we're working with a triangle. All right, so we got 180. Angles of triangle add to 180, so I'm going to subtract the 90 degrees, this right triangle here, right angle, as well as the 63, and what we're left with is 27. And so angle 3 there would be 27 degrees, right? Because angles in triangle add to 180. Cool. All right, so one more here. So for number 20 here, again, we got a parallel line, 2 parallel lines. So to find angle 4, just this angle here. Again, it's a good idea. What I do here is I trace the angle that I'm looking for and then try to find something that it connects with. And you notice here that it connects with this 34 degrees down there. This is a Z angle, or alternate interior angles. That's what it's called. So angle 4 is equal to this 34 degrees. Okay, so that is 34 degrees. Now angle 5. All right, so again, we have angles on a line. This is 90 degrees. That means that the angle 5 there must also be 90 degrees because angles on a line add to 180. All right, so here we got 90. And to find angle 6, actually there's a couple ways. Perhaps the most obvious one is that we're dealing with a triangle. So we're dealing with a triangle here. So we can take the 180, subtract 90, and subtract 34. That will give us 90, 56 degrees. All right, cool. Now the other way, another way, perhaps that we could have found that angle is take an eraser to this red triangle. All right, so the other way that we could have found it is that notice that this line here is parallel to this line, so this creates a C angle. Right, so anyways, angle 6 plus 4 plus 90 must equal 180. Right, so again, we're going to take the 180 because C angles add to 180. So I'm going to take the 180, C angles add to 180, subtract 90, subtract 34. You'll notice it's the exact same equation as I used when I was applying the triangle. So again, we're going to get 56 degrees. Yeah. All right, cool. So that is, that's just kind of a lesson on triangles here. All right. So I'm just going to open up this the package here, just kind of show you. Zoom it in. All right, so on your package, again, you'll come across this page here that summarizes the notes. All right, so this is after the last one you worked through. Okay, so this summarizes the concepts, and again, just practice through this worksheet as well as this one here. All right, and just stop when you get to the geometry review. Cool. All right, guys, so that's that lesson on triangles. Cheers.